Hello, everyone. We are presenting interpretable multimodality popularity prediction. Nowadays, millions of stray animals are suffering. Taking good picture of them to arouse more sympathy can let them be adopted faster. Indeed, a picture is worth 1,000 words. Thus, our research question is how to take a good picture to maximize the popularity. For example, whether including a decently clean face or eyes facing front or near front will improve the popularity. Our dataset can be divided into text and images, where text is a CSV file containing features and popularity scores. Features is a set of characteristics related to appearance. Popularity is a measurement of popularity of the pet. Each row in the metadata is corresponding to an image. For the raw images, we'll do image downscaling as pre-processing technique.
Now we'll talk about our model. The name of the model is pawnet. The metadata is used to train a decision tree. And we train the raw image data on a CNN we designed, calling it pawCNN. Finally, we took an average of the two models' output to get our final prediction. Now we will talk about our two submodels.
Now we compare our models to existing works. We choose decision tree as our shallow model, where lots of people choose SVM or random forest. These models may outperform decision tree with proper hyperparameters. However, as they are relatively complex models, SVM and the random forest lack interpretability. For CNN, many existing works use convolutional layers followed by a fully connected layer, while we use a structure called coral layer in place of fully connected layer because they perform better on our data. The coral network basically treats targets as ordinal variable. Then for each possible ordinal value in a given domain, it outputs the predicted possibility that the true value is larger than this value. The model then takes the prediction based on these probabilities.
For the evaluation metric, we will use the root mean square error. For the shallow model using decision tree, we compare the performance using RMSE on normal dataset and PCA. Using K-fold, we can see that the normal data outperforms PCA in terms of mean, standard deviation, and also a higher interpretability. Then we will use K-fold for hyperparameter tuning in decision tree regressor.
Now we try to incorporate the idea of ResNet into our CNN. ResNet improves performance of deep neural network by adding shortcuts to skip layers. We modify our model by adding such shortcuts, but the result doesn't improve. We believe that the reason is that our model isn't deep enough to see the benefits of ResNet.
We compare our model's performance against several deep and shallow baselines. As you can see, our model outperforms all deep baselines and almost all shallow baselines, with about 5% performance advantage over all deep baselines. Our model achieves the state-of-the-art performance. Plus, our model features interpretability. That's something most other models don't have.
Our model has high interpretability since we can find the features that determine the popularity most. We can see that blur, which is the pet's eyes and face are noticeably out of focus or noisy, is the most important feature. Also, group, which is a picture has more than one pet, and also accessory, which is with physical or digital accessory, are also important determinants.
For the deep model, we use an algorithm called GradCam for interpretation. The algorithm is simple. It first computes the gradient of the score for class Y. These gradients are average pool to obtain the neural importance, alpha k. And then we perform a weighted combination of forward activation and follow it by a ReLU activation to obtain a heat map explanation. So here's the heat map. As we can see, the deep model explanation provides another perspective. For the most of the samples, like the live one, the pet itself is the most important factor of the popularity of the image. However, if the pet is too small, like the right picture, we found that the background may have a high correlation with the output. We believe that background is a distraction and will have a negative impact on the popularity. All right, thanks for listening.